This is the mastery topic video for numbers 9 and 10. For number 9, it tells us we need to find the x and y intercepts of a quadratic. In order to find x-intercepts, we plug in 0 for y. In order to find y-intercepts, we plug in 0 for x, no matter the format. So if we look at example 1, let's try to find the x-intercepts first. So again, in order to find the x-intercept, we plug in 0 for y. We end up with a quadratic equation, which is already set equal to 0, so all we need to do is factor that right side. So look for factors of -3 that add to -2. That gives us -3 and +1. Go ahead and solve, set each of those equal to 0, and we get x equals 3 and x equals -1. Because they're x-intercepts, we're going to write them as ordered pairs, so that means +3, 0 and -1, 0 are the two x-intercepts. In order to find the y-intercept, we plug in 0 for x. Whenever we plug in 0 for x in a standard form, we always end up with the constant as our y-intercept. So we can just look at the constant, or we can keep plugging in 0 for x. It doesn't matter, but we end up with y equals -3. So again, write it as an ordered pair. Plugged in 0 for x, got out -3 for y, so our ordered pair is 0, -3. Let's look at our second example, which is in vertex form. We're still going to do the same method of plugging in 0 to find for the y to find the x-intercept. So we get 0 equals -2 times x plus 1 squared. The first thing we need to do is isolate what's being squared, so we're going to divide both sides by -2. Then in order to undo the square root, I'm going to go backwards a little bit here. In order to undo a square, we take the square root of both sides. Then we end up with 0 equals x plus 1. After that, we can subtract 1 from both sides. We get an x value of -1. So for this problem, we do only have one x-intercept, which is -1, 0. To find the y-intercept, plug in 0 for x. Go through your order of operations, making sure to do the exponent before we multiply, and we get a y value of -2. So our y-intercept is 0, -2. Everyone's favorite, completing the square, comes next. This is topic 10. So if we look at the first example, the first thing we need to do is get the constant out of the way, because it doesn't make the trinomial perfect. So I'm going to add 5 to both sides just to get it out of the way. So I have y plus 5 equals x squared minus 4x, and I left room on purpose, because we need to find that magic number that's going to make our trinomial a perfect trinomial so that we can write it as a binomial squared. We find that by taking the linear coefficient, dividing it by 2, and then squaring that number. So for this example, we're going to take -4, divide it by 2, and square it. We end up getting +4, so we add that to both sides of the equation to keep the balance. So the left side becomes y plus 9 when we combine like terms, and the right side we can write it as a binomial squared now. We completed the square. So you take the middle term, divide it by 2, so that gives us x minus 2, and square it. If you guys want to factor x squared minus 4x plus 4, you can do that, and you will get x minus 2 times x minus 2, which we can write as x minus 2 squared. The last step, in order to get into vertex form, we need y by itself, so we're going to subtract 9 from both sides. Then we're done. We are not going to do example 2 because we did not talk about how to do them when they have a coefficient other than 1. This concludes the video.